So first of all, a set of acronyms and definition we are going to use in the presentation deck. So AF means address family inside the multi-protocol BGP routing, EVPN, L2 VPN, MPBGP, EVPN. ORF stands for outbound route filtering. CE is customer edge router, so under the administration of usually the customer, and PE provider edge router under the administration of a service provider. Before going to outbound filtering, let me just rewind a little bit and just as a reminder of what route filtering is. So this is a mechanism that will allow you to remove routes entries from being added in the local routing database, in the local routing table, or eventually not advertised to peers. So why we do route filtering? So there are many reasons. One of it is for large routing tables like internet routing table that consume a lot of memory and CPU. You may want for reducing the number of CPU cycles to reduce those number of routes. So that's an economic reason. Then we've got some routing engineering that would be, for instance, you want to avoid the traffic going through a circuit where the bandwidth on which the bandwidth of that circuit is limited or circuit is overloaded. So you tune your prefix list so that you do not go over that link for those specific prefix. Then there is a third one, which is security. On top of access list, you may want to make sure that there is the routing that will also control on which point you exit or you enter. And as well, anti-spoofing means that, for instance, I want to make sure that I'm not going to receive routes for the domain that I'm controlling. So specifically, I will not receive any routes from a service provider for routes that are supposed to be behind the CE. So that's obvious, but this is best practice anti-spoofing rules for routing. And those filtering direction could be inbound or outbound when you apply a route map with filters on a neighbor, on a BGP neighbor or a BGP peer group. Now let's go back to a problem statement that we initially was thinking of for the economic reason to minimize the number of BGP tables. So that was the first use case that drive the creation of that new feature, the outbound route filtering. So this is a PE that advertise many routes to the CE. And the CE will only require very few of them. So the CE will have to process all the prefixes and deny them individually, one by one, which will increase consequently the CPU and the memory load on the CE. To reduce that computation, we would like the PE to send to the CE the only necessary prefixes for the CE. So this is an example of what happened right now without outbound route filtering. Here you've got a PE in let's say in an autonomous system and a C in another autonomous system. The P is sending a bunch of routes that you've got here. So this is the, let's say, 20 prefixes that he has in this table. If you want to process and reduce those prefixes on the CE, what you do, you create a prefix list. You create a route map that match on that prefix list, and you simply apply that route map inbound for that particular neighbor that is the PE. After that route map has been applied and processed, you will see on the CE only the routes that are permitted through that prefix list. Okay, but you will see as well that the CE is receiving all the routes from the PE. So here, this is the table. When you do a show BGP IPv4 unicast neighbor, the IP of the neighbor, receive routes, you will see all the routes received from the PE, and only those three that are permitted in the prefix list are actually in the BGP rib for candidate routes in the routing table. So, but you see all of them are here. So in order to avoid that processing, we'll have outbound route filtering. And how you can see, by the way, just a reminder, how you see those received routes. So if you do not configure anything, if you try that command, you will see that number of entries is 0. Why is that? Because on the CE, if you look at the show BGP IPv4 unique as neighbor, you will see that there is a soft reconfiguration in that is not configured. So the CE will not retain all the BGP neighbor cache entries that he has. He will simply just remove them. In order to retain that cache entry, you have to configure soft reconfiguration inbound locally on the CE to be able to maintain those cache entries and to see the routes received from the PE. Okay, and as you can see here, software configuration in is enabled on the status of the neighbor. So that's just something to remind when you are doing troubleshooting. If you want to just check the routes that are getting from the PE, you will need to activate that. So going back to outbound route filtering, this is the capability that provide a way for BGP speaker to send to its BGP peer, so the C sending to the PE, a set of routes filters that can be used by its peer, so the PE, to filter its outbound routing updates to the requesting neighbor, so the CE in that case. So this is very smart because this is a filter method that is used to reduce the computation on the router that will receive the route updates. So uh, now you could eventually say that the inbound route map is technically no longer required to deny those prefix lists based on the filter list sent by the CE to the PEs, because the PE will simply not advertise back to the CE the routes that are unnecessary. So this is very smart way of filtering. So here in the drawing, you see that the CE has a prefix list configured on it. That RC will suggest that list to the PE through a specific BGP message that we are going to see later. And then the PE receiving that list will advertise back only the necessary prefixes to the CE. Let's move on. If there are questions on the chat window or on the Q&A, please go through the Q&A first. We are going to answer that either online or live. So use cases. Use cases for that is really influencing a filter for another administrative domain. So that capability, that ORF capability, is, I would say, a cooperative route filtering capability. On both peers, we must support the ability to send the request with the given prefix list we want the neighbor to filter on. And we want to have, obviously, the peer that will be able to receive that request and receive the prefix list. That is indeed very useful to control um, from a router, to control the outbound advertisement that is done on a router that is not belonging to the same administrative domain, the same autonomous system. So all that filtering customization, the customer cannot do that on the PE equipment. He has no access to the PE equipment in terms of CLI or whatsoever. So, but he's asking that through a protocol, through that capability inside the BGP, the CE is asking the PE to filter. So this is bringing a lot of flexibility to control the routing. Again, the main use cases, so large routing table to minimize the massive inbound route filtering that the CE would have to perform. And as well, something that it's useful as well for operational enforcement. So let's say the receive routes are filtered in two places. The traditional inbound route map filtering that you have on the CE, so you keep it. And the outbound a roadmap filtering, so the outbound ORF route filtering that you have from the sender, from the PE. So this provides an extra protection mechanism in the sense that if you've got human error performed on one route map or one prefix list, it's unlikely that human error will also impact the second prefix list used for the outbound route filtering. So this is a way to enforce operation. Usually the prefix list defined in the inbound route map will include the entries in the prefix list used for the outbound route map filter, the outbound route filtering. And the content of both prefix lists could be the same. We'll see that in the best practice. Last point is that although this is not restricted to external BGP, there is very little interest to use outbound route filtering inside the same autonomous system or the same administrative domain, because you have control of all the switches or routers inside that domain. So details and caveats. So first of all, in terms of platform support, so we support ORF on all the CX platform except the 6200, where we do not have much support for routing and for protocols. And we support that for IPv4 address family and IPv6 address family, not for EVPN address family. In terms of scale, the maximum number of prefix list entries in the outbound route filtering prefix list that is sent to the from the CE to the PE is 128. The maximum number of prefix lists that a CX box can receive from acting as a PE from CE would be also 128. So about interoperability, there is a warning here. If there is a third-party ORF sender C that is requesting a CX switch as an ORF receiver to filter more than 128 entries, so it could be the case, RFC would permit that. It might work, but it's not tested, right? So consequently, this is not supported. Again, this would be an ad hoc case-by-case consideration and test to be performed. Also already raised, this apply only to IPv4 and IPv6 address families, not EVPN. So the reason for that is that in Helen, in AOS-CX, the underlying mechanism to support outbound route filtering is a route map mechanism that is used inside the infrastructure internally on the sender and on the receiver. As we do not yet support route map inside the EVPN address family, ORF cannot be supported yet for that EVPN address family. There is a verification pending currently. If you activate inbound soft reconfiguration, and we'll see a slide about that, that will prevent ORF from working on the PE. You still have route filtering that will happen, but instead of being done on the PE, it will be done inbound of the CE, just like a regular inbound route map. So there is some verification on that one that will be clarified, and we will update the slide deck on that. Maybe one of that would be that inbound soft reconfiguration require the entire neighbor RIB to be stored. And so we'll have some mutual exclusion of the way the prefix list is being sent to the PE. Again, we get a slide updated on that one. Some important caveats: how we can refresh routes after you modify actually the prefix list for outbound route filtering on the CE. So let's say you have to include a new route, or you want to exclude the new one. How you are going to change that? So if you modify the prefix list, it's not going to trigger any route refresh message to the neighbor. The session must be soft resetted. So the BGP will support two methods to reset or to clear a BGP session. You have an hard reset, which is highly disruptive because it will simply tear down the BGP session. So it's a complete TCP socket renegotiation, and so you will remove um, the BGP routes from the peer, or a soft reset, which will just simply clear the cache and request a full advertisement from the BGP peer. So that one is not disruptive. Route refresh capability on CX is always enabled. You cannot disable that. And this is the case also for most vendor in the industry supporting route refresh. So maybe you will see some old equipments that do not support route refresh. Okay. So if route refresh is supported, which should be the main case, on the ORF receiver, the soft reset of the BGP session on the sender, the one where you modify the prefix list, that soft reset will trigger a new route refresh message from the sender, and the ORF receiver will send route updates according to the new received ORF prefix list. If the route refresh capability is not supported on the receiver, then the BGP session has to be hard reset, and that would be disruptive. So next slide is about way we have to pay attention on some of those items. So the same ORF prefix list can be used for multiple neighbors at the same time. So there is no dependency. You can use well, obviously as well, a unique ORF prefix list for each neighbor. If there is a route map that is used inbound that is applied on more than one, on multiple neighbors, along with the usage of ORF, then the route map name for each of those neighbors must be unique. So you must have a different route map name used for each neighbor. So pay attention on that one. The next one is if the route map inbound is also applied on the BGP neighbor for the EVPN address family along with ORF, then the route map sequence number um, number one cannot be used. Okay, so that's also something that needs to be considered because there is no warning in the CLI for that. You will get no error, but it might not work. And finally, we have successfully tested ORF interoperability with Cisco. We'll get back to you with the list of platform on Cisco that it has been tested. Okay, so let's go into some details. Here we have again PE and CE, and we have a BGP open message that is from the PE to the CE. So the PE, this is all about explaining you the capability that is being exchanged. So here the PE should be capable of receiving the route filter. So as you can see here, this is a Wireshark of a BGP open message. And if you open down the optional parameters, you'll see all the capability being exchanged. And you see a send receive for ORF, so cooperative route filtering capability, as received from the PE. So the PE is able to receive request from the CE. Please note that the Wireshark, in Wireshark, there is decoding that is not very well done if you configure both IPv4 and IPv6 address family. So if both are configured, the capability decoding is not, it has to be done manually based on the RFC specification of the packet. Same aspect on the C. The C in the open message will send its capability for outbound route filtering, and it will specify that as a send. Obviously, you can configure both as well, send and receive, but I'm just specifying the strict minimum requirement that you have here between a P and a C as an educative purpose, but you could have both as well. Same here, here. Warning: if both IPv4 and IPv6 are configured, Wireshark dissection issue might be seen, so that it needs to be done manually. And then how the CE is exchanging the information about the prefix list. So there is a route refresh message that is sent from the CE to the PE, where you have the outbound route filtering information field. So this is in Wireshark, you will see that. Again, on Wireshark here, that's the second point that we have to share. The decoding is not working properly. So you will see information, but you will not be able to actually see the prefix list, decoding the prefix list. It has to be done manually by dissecting yourself the packet with the RFC specification. In order to help on that a little bit, I just put here TCP dump that is done on the PE and on the C next slide, just to have an alternate view of the Wireshark that will provide you actually a bit of better clarity of what I was saying for decoding the prefix list. So this is on the PE. Here you retrieve the capability. You retrieve the updates message later on that the PE is sending. So you see the updated routes that the PE is sending after it did perform the outbound route filter. And on the C, the route refresh message, if you capture the TCP dump here, you've got the Diag utilities, TCP dump verbosity for traffic for the destination being the PE. So that's being collected on the C. You will see the route refresh message, and here you see a bit more details, clearly this is the ORF prefix list with the starter, the marker for starting, and then the information about in hexadecimal, the information about the prefix list. So you cannot still very well decode the associated value, IP format value of the prefix list, but it gives you a quite good hint of if this is not if this is empty or not. That's what I mean. And again, if you've got software configuration in, you'll see that this list here is much smaller than the one on the right side. So this is without software configuration in that I was mentioning before, introduction of the topic. And here you see that you are missing some part of the prefix list. So that's this is under checked, and maybe there will be an updated on the slides about that collaboration or exclusion between software configuration in and ORF. So pay attention on that if the customer is using software configuration in. Configuration, how you configure so this is done in two steps, whatever you use that in IPv4 or IPv6 address family. First, you enable the ORF capability. So this is to notify the neighbor about the ORF capability in the open message. So typically the PE will be configured to receive request and the C to send ORF request. So currently the list, the filter type that is being used to filter ORF is only on prefix list. You have the RFC specify other filters capability, like ISPAF filter and so on. For the time being, only prefix list is supported. And then on the CE, you will configure the prefix list as such. That is used in the inbound direction of the CE. So that prefix list to be sent to the PE. The C will send, as we saw, the prefix list to the PE in the route refresh message. And the prefix list received at the PE is used to filter outbound towards the CE. So again, this is the CE, this is the PE. The capability is configured. So this is under the IP, the address family here. This is IPv4. And you configure with the neighbor IP address of the neighbor, capability ORF, prefix list, send for the C, and for the P that will be received. only on the C, you will configure the prefix list. So the prefix list here, you will see in the next slide how to configure prefix list, but just applying the prefix list, that would be neighbor, the PE ORF prefix list. So this is the prefix list to be sent to the PE, requesting the filter to be efficient on the ingress of the C. So as a baseline, so this is an example. Here I start without any ORF. Okay, so this is very simple configuration with BGP statement. Here you see in a neighbor with a different autonomous system, IPv4 unicast address family being used. And then if I do a show BGP neighbor, you'll see the ORF capability that is none, okay, because it's not configured yet. Okay. As a matter of fact, the P has all those entries, those routes, and the C will receive those. No filter. If you configure capability ORF on the P to receive and on the C to send with the prefix list. So here, this is an example of a prefix list that is used. Okay, so you just configure the prefix list. No route map configuration that is required here. You will make a reference of that prefix list to be used for ORF with that command, ORF prefix list in. Then, if you look at the show BGP, you will have the ORF capability that is appearing here as receive for the PE or sent for the C. Again, it could be both. The outcome, you see that we still have the same routes on the PE. However, the C will consequently have only those three: default 10.1/16, 10.10/16. Best practices. As I mentioned before, we've got obviously the use case that is to filter a large number of routes, but for enforcement, it's useful to note that please use different prefix list name for ORF and the route map inbound filtering, so that if there is a human error on the prefix list used for inbound route map, it's unlikely to have also the same human error being performed on the prefix list used for outbound route map filtering. So this is a way to enforce control of routing. Anti-spoofing for ORF, if the CE should not receive prefixes advertisement for routes that are supposed to be behind the administrative domain of the CE. So it can be also a way of using ORF. And then I hand over to Ravindra for troubleshooting and demonstration.
So let's get started. So as part of troubleshooting, we have added a new command, which is basically to check the received prefix list at the PE node, which is basically show BGP IPv4 or 6 unicast, neighbor IP, and then the received prefix list. So this command will basically tell you that whether P has received a prefix list from the C to be applied for the filtering or not. And it will list you all the sequences and the complete detail actually, right? We can, apart from this, we will also see as part of demo the existing command where we have added a few details. For example, the neighbor command and the in the neighbor command where we have the ORF capability part captured. So we'll go to the next slide. Yes. So as part of this show BGP neighbor command, we can see that if we have the ORF capability enabled, so we can see that ORF capability as receive or send or both here. For example, this is for the PE node. So we can see the ORF capability is configured as receive. ORF type will be always fixed to prefix list because we only support the prefix list based of filtering. So apart from this, so there are other advanced troubleshooting things that we can do. For example, we can check the diagrams. So DAG dump BGP all or DAG dump BGP MIB can be dumped, and we can check these additional tables, BGP peer ORF capability, to be able to check the capability configured, the route map table, and the peer officer fee table. We have few Fastlogs, so that can be checked using this command, OVS-APCTL command for the BGP dump, and we can check few ORF Fastlogs that we have dumped there, which will basically tell you where what capability and for which address family and for which peer it is configured. So as part of troubleshooting, we have so we'll see all this how in the as part of the actually. We'll move next. So currently we don't have any event log for this ORF feature, as we don't require for this feature. So we'll go to the demo part. But before this, I can just tell you this is the same topology that we're using. So P will be advertising few routes to the C, and we'll see that when we apply the ORF and we remove the ORF, what is the difference? Where basically P will be sending all the routes. When we apply the ORF, P will be sending only the filtered routes to the C. So we are going to see this in the demo. So we have two nodes. This is the ORF C node and this is the ORF P node. So P node is advertising three routes to the C node. We can check those routes here. We can check using advertise routes command. This command will be helpful. So we can see that P is advertising all the three routes it has. You can also check these routes at the C node with the same show BGP all command. So we can see that we are receiving all the three routes currently. So currently ORF is not applied because it is not there. It's not applied on the C node currently. So I'm going to add the ORF configuration on the C node, and then we'll see the how the ORF is filtering this. As we saw in the slides, so we need these two commands. There is the capability command. So we are at the C side, so we need to configure the capability as send, and at the P side we need to configure the capability as receive. So we have the capability receive configured already, and here, and we have to C node has to send the prefix list. So we have to configure that ORF prefix list P1 in. We have to mention this direction. However, this is the default we have. So P1 is the prefix list that we have configured, which is going to permit basically two routes, 10, 10, 10 and 20, 20, 20. Other routes will not be permitted. So we have applied this ORF. Now, as Vincent said, we have to apply, we have to do the clear, actually clear soft in or clear hard we have to do. So So after applying the ORF, we can see that the route 30 got filtered actually. So C is so how to make sure that C is no longer receiving that route and the filtering is not applied in the inbound, we can also check this at the P side. So we can check the same command, advertised routes. So we can see here earlier the advertised routes was all the three routes. Now we can see the earlier the 30 was also being advertised. Now we can see 30 is not getting advertised. So basically, C has sent that prefix list to the P node. P has applied that as filtered in the out direction while sending the routes to the C node. You can also check that prefix list command actually. So this is a new command that we have added. So we can see that the P has received this prefix list with sequence 10 and 20 from this particular neighbor. Right. So let us see the Fastlogs also. So we have few additional details as well. We can see the capability part here. We can see that the route mapping for this particular neighbor is applied as the ORF is implemented using the route map infra. That's the internal detail. Right. So that's all I have on the demo part.